So we appreciate you, as Jason mentioned, coming out to Vegas today. You could be anywhere in the world, but you're here with us. Didn't get trapped by the electronic music conference, or get trapped people watching people coming back from the electronic music conference this morning. So myself, along with Jere, Julian, we are with Network to Code. We have the privilege of presenting Beyond Configuration Management, or as we say, what to do with your automated networks. Now, we also have the privilege of being the first live demos. So as you know, we're either going to be kings when we leave, or we're going to flame out in a ball of glory. So either way, we're going to have some fun. All right. The purpose of the talk today is just to say, what can you do after you start automating your networks? Where can you go? How can you provide value? And what can we do? So we're going to go through just some slides going over some basic principles that will be covered a little bit later in later talks, and then we're going to get into some live demos. And hopefully you won't be booing us and throwing tomatoes and cans by the time we leave.
Bring them on.
All right, so a little bit about myself. Again, my name is Darren Johnson. I am a network automation engineer with Network to Code. That was my boss that just got done talking. We're a network automation company. We like to joke and say we're the network automation company because we feel like we are. I'm based out of Detroit, Michigan, as you can see, Motor City. That's a very proud thing for me. I've got about 15 years in network and systems engineering. And in that time, I worked for small and medium-sized service providers, really large enterprises with some people that are here today, and also a startup, Network to Code. I can quote SIP RFCs. For some reason, I did a jaunt into VoIP territory, and that caused me to be able to recite to you all the problems with VoIP. So I got out of there and went on to network automation. But that's what gave me some practical experience with Linux and systems engineering and all the problems that you encounter when you deal with users. Also, I almost died last week. If you see the pic, I had my first time going to Yosemite, ran a half marathon, and I'm proud of it, not for my time, but the fact that I did not die, and I'm here with you today. So we'll turn it over to my counterpart, Jere.
Thanks, Darren. So I've been everything from running networks in educational settings to manufacturing to then getting into the vendor space, and interestingly, getting into network automation before it was even called network automation. And back when we used things like Tickle and screen scraping and Inspect, for some of you that might recall those things. Hopefully, we're moving beyond that today, but I know there's still quite a bit of that out there. Gotten to work through multiple vendors, and finally was able to break free of that vendor space and get into what I consider the more vendor neutral space now. Being here with Network to Code has been, it's been really exciting because very few people have a single vendor network, right? So when you're working for a vendor, there's problems you want to solve that you don't get to because you're so focused on that vendor's area. So this has been, this has been a really fun adventure, and getting to play with all the variety of toys we get to. And I'm really looking forward to Darren highlighting some of these cool interactions that we can get. And everything that we're going to show today pretty much works across just about any type of device, any type of system. But we want you to even think higher than that. Let's spend a little bit less time focusing on devices. And we'll get into this more later, but let's think higher. Let's think about what we're trying to accomplish at our companies. What are our business goals? What are the things that really hurt day to day? Is it actually configuring your devices? Or is it all of the interactions with other tooling that we have too? So hopefully we can give you guys some great ideas. And then we have other folks that are going to dive deeper into some of these more specific areas. But if you have any any questions along the way, we're always happy to go into more details. Catch up with you on the breaks, or at lunch. We have some times that you can schedule with us as well. So, there you go.
Awesome. So there's a mantra, or kind of a MO, as you were, that we like to continuously cement down into your head. So when it deals with network automation use cases, you want to automate, integrate, and orchestrate. And automation is not the end, as Jason mentioned in his talk. So effective network automation, it normally starts with configuration management. What we want to look for is how we can go beyond that. But it's a necessary step to go through configuration management. A unit of config is how all network engineers measure what is actually going to be on a device. Right? If I want to instantiate a switch port or an interface, the easiest way to determine what's on the interface is looking at a unit of config. So starting with configuration management, as you see in most of the tutorials that are out there for network automation, is a good necessary step. And what that enables you to do is to get into simple, quick wins. You get into, hey, look, I can deploy VLANs 100 times a day. I can deploy new switch port interfaces. You can go as crazy as to say I can stand up new BGP peers 100 times a day if you're crazy enough to do that. And that's what configuration management gets you. It also gives you the ability to make things repeatable and measurable. And that's important when you're dealing with effective network automation. You need to be able to repeat a process, but it's also important for you to be able to measure when that process is done. You need to be able to measure the state prior to a change or a implementation of network automation, and you need to be able to measure the state following the change. So what that gets you is, what can I do? So look what I can do. But the important step to get to is, what can you actually do with it? And the reason is, to make a bold statement here, network automation by itself is boring to everyone but you. Now, the reason for that, I'll substantiate it, is if you go to your boss, if you go to your VP, if you stand in front of a presentation attempting to get buy-in from business resources, which is who pays all of our salaries, and you show a unit of configuration, you show a switch port, you show a router config, they're going to smile at you. And they're going to talk about how you wasted months of time just being able to configure a router. However, if you show them that what the value add for this unit of config, these changes do, the return on investment for these months you've spent, now you start to get business buy-in. And ultimately, that's important because we all need salaries, right? It all costed something to get here. We also need to be able to move network automation forward. In order to do that, we need to get buy-in from different business units, and we need to integrate with other services. Now, because of that, you have some goals of network automation. Now, Ken and Jere are going to go into a presentation later that's called Network Automation Principles. And they're going to go into a very deep dive into these goals for automation and these principles, and why network automation by itself is boring. They're going to substantiate that a little bit more. But clearly the goals for network automation is to expose network services and functions to users safely. And what do we mean by that? We're going to do that by what's called opinionated interfaces. What we do as network engineers, or as network developers, as network automators, is we're going to control how people can consume the network. We're going to say you can deploy these VLANs on this port channel, but only these VLANs within this range. You can only add a range that has been input into our CMDB, for example. You can't shut certain interfaces, but you can turn up new switch ports. Now, by doing that, what you're doing is you're jailing your users in a very secure and manageable fashion. You're controlling what they can do, and you're also enabling them to integrate and consume the network. What you should also do is aim to automate workflows, not just functions. Don't just automate a unit of config, but automate the workflow that can consume that unit of config. We're going to show that a little bit later. Also, we want to integrate with our source of truth. If you know anything about a source of truth, as my illustrious colleague Ken says, if you have multiple sources of truth, you have no source of truth. What that means is we need to integrate with our CMDB. We need to integrate with our device management. We need to integrate with our discovery applications on our network in order to allow us to control which devices we operate on. By doing that, we're going to meet our users where they already are. What does that mean? Well, for your business users, you want to meet them in a ticketing system versus another GUI. You can produce the most impressive, the most pretty, the most JavaScripty, as it were, GUI possible. And if your users have to enter a different password, if they have to remember the site, 9 times out of 10, they're not going to go there because what they're going to end up doing is copying information from an interface that they already use into your new pretty interface. So it may be more beneficial to meet them where they are in the ticketing system. For your devs, provide them with an API versus another web form. Web forms can be fantastic. However, APIs allow you to integrate. For your ops teams, provide them with alerts and metrics versus emails. No matter how much we love Slack and communication, we can't get away from email, but email fatigue is a very real thing. So provide them with alerts and metrics that integrate with the systems that they already use to measure performance and security on the network.
So you're saying meet them where they are instead of giving them a bunch of new tools?
Yeah. If you present someone with a brand new tool that does the same thing that they did before, how often are we to use that tool?
And if it's more difficult to use this new tool, how likely are they to use that? If there's a huge learning curve. But if they're able to just jump in an environment they're already used to and suddenly have some new capabilities, then that's hopefully going to be far easier for them to get involved with, to get on board. And your real goal is to make automation easier than their current set of tools they're using.
Yeah. Simplify their life. Make it an IKEA instruction rather than a Chilton manual. I'm dating myself with Chilton manuals. Finally, allow orchestration from the OSS BSS systems because that's going to give you buy-in and build a network automation framework. That doesn't mean that you have to be the best software developer and you have to build a entirely scalable distributed system application. However, leverage the tools that are already in the business in order to build a framework around network automation. Now, what do we mean by that? Let's actually put some rubber to the road. Network automation integration here. So what we see is we have Slack that you see Ansible Tower in the middle, right? Ansible Tower in this instance, or AWX, is serving as a low-level API, right? It's an API that is a gateway between all these disparate systems. We're all here, for the most part, writing playbooks, writing salt files, or writing some sort of tool that provides us with our automation. So we'll say that is our automations. Those are our units of config. Those are the changes that we're actually going to use. Now you can swap out Ansible Tower for your tool du jour. But the point is, those blue arrows show the integrations and the orchestrations that other tools can do to interface with the network infrastructure that's down below. I don't draw really pretty pictures. Those are switches and routers. But the network infrastructure that's down below, and you're doing that in a controlled way. So Slack can provide you with a chat integration. Mr. Shulman is going to talk about that in greater detail later. But we'll show a bit of a demo a bit later about how you can use that. Slack provides your users with the ability to interact with the network in a controlled way. So perhaps you have junior engineers or you have business analysts that want to do something as simple as to say, how many interfaces are on this switch? Right? Show IP interface brief. You don't want to give them TACACS access. You don't want to give them the ability to go in and run those show commands, but you can provide them with a channel in their Slack interface or insert chat tool and provide them with that ability. It could because it gives you customized control access to the infrastructure. And you can do that by leveraging the playbooks and the SALT tools, or whatever your automation tool is that you're already writing. Finally, for your source of truth, my distinguished colleague, Jonathan Anderson, and also Jeremy Stretch, they're going to talk a lot longer about NetBox, but pick a tool, pick a source of truth. Use that source of truth. Use that as the de facto standard for what is actually on the network and how the devices should be. Now what you see in this instance is there's a two-way arrow that goes between NetBox, which is here, our source of truth, and Ansible Tower. What that gives you the ability to do is to query NetBox and say, what is this device? What kind of device is this? What interfaces should be on this device? What should this device be doing? Is this device that I'm attempting to access even in a CMDB? It provides metadata and functionality beyond belief. Starting to build those integrations and starting to leverage those will help you to not just automate, but also integrate and orchestrate as well. And lastly, you see ServiceNow. We all have a ticketing system, love it or hate it, we have to use it. That's the interface with the business, the operations, and that's where also the developers meet. Some of us worked ops before, and we worked tickets, where the tickets are generated by that ticketing system. Why not allow some automated provisioning within a ticketing system? Why not leverage the ticketing system and your network CMDB together? But you can do that with the playbooks that you're already able to write. We're going to show that in a little bit. So before we go into the demo, do you have anything else to add? You can flame out. All right. So if you have a deity you believe in, send me some help here. All right. So the first scenario we're going to go over. Brad fixes the network. On my left, you have Brad. He's a junior engineer. He knows everything that there is to know about networking because he took 2 CCNA classes and got his CCENT, and he's going to fix our Fortune 500 company's network. He's going to do that by this newfangled automation that he already knows how to work. On the right, you have Jamal, who is Brad's boss. He gives him a very, very secure way to access the internet via CI. Everyone talks about CI and CD, right? The CD is what gets highlighted. CD meaning continuous delivery. But the CI, the continuous integration, is where, for network engineers, where we're going to see the most value. It is slightly unrealistic to say that all of the network functions that we use, we're going to deploy those constantly 100 times throughout the day. No matter what our brothers in arms in the cloud world tell you, for a lot of us, it's very unrealistic to redeploy our app, which is a huge distributed system called the network that is the moneymaker for many businesses, that we're going to redeploy that every day. But what we can do is provide some CI, continuous integration, meaning that we can lint, we can run automated tests, we can determine if something within a certain measure is going to break our network. And how do we do that? Well, we do that by leveraging source control. Hopefully now you're already putting all of your network changes in source control. If you're not, that's a good goal. It's a very small investment that has huge benefits, right? You get automatic versioning, you get different visibilities. By putting your network changes in source control, you're able to leverage some of these tools. The CI piece does linting and validation in the demo that we're going to show. What it does is upon pull requests or pushes to a certain branch, a certain repository, we're able to say, run this battery of automated tests. So all the things that Brad's boss, Jamal, would do via his eyes, he can just write a test for it. He can test whether Brad is in fact going to fix or break the network. You also get text output notification, which we're going to show as well. Now the tech stack involved. We at Network to Code, we eat our own dog food, and so to speak. You leverage our tools. You may have noticed the blog post that was put out a week or so ago. We have a tool-free framework, as it were, called the NIT, right? Automated Network Infrastructure Testing. What it basically is, it's a library that will test network changes based on a series of tests. And it will test the expected config, or a small microcosm of the expected config, versus the actual config. So long amount of buzzwords for basically to make sure that Brad doesn't break the internet. And we validate these tests against different Python and Ansible versions in case we're using Ansible 2.8, for example, on our laptops and 2.6 in production. Leveraging tools like this and the CI methodology can let you make sure that the changes you're intending to use don't impact the network in a way that you didn't anticipate. Finally, we're also going to leverage GitHub Actions. Why do we choose GitHub Actions? It's free. We all have some sort of CI tool that our developers are using in our enterprises, be it Jenkins, be it GitLab Runner, be it Travis, different tools. We're just going to show GitHub Actions because it's a very low-cost way to automate, integrate, and orchestrate. All right, so again, we're going to flame out in a ball of glory, but we're going to see some demos today. Okay, so can everyone see that? Is that visible? Yeah. Cool. Awesome. Okay. So let's go over it very quickly. A quick look at README coordinate. Quick look at one second. I'm just gonna look really quickly. Here we go. So again, as we mentioned, and it is a framework that approaches network testing how traditional unit testing is done. What it does is it leverages Knox, as well as Ansible, right? And within Ansible leverages Gender templates. For the most part, we're using Gender templates to instantiate units of config or to template out a change that we're going to do in our network changes. And what this does is it runs a battery of tests that you define against the changes that you're attempting to implement. So basically, it makes sure that your expected config from the change that you're going to make and the data inputs that you provide will come out to look the way it needs to. And ultimately, because the unit of config is measuring how we're actually going to interact with the device, it's going to make sure that what you're attempting to do won't damage your devices. The way it does that is through a template structure like this. So you have different, we call meta, or different facts upon a device. And what you can do is you can leverage vendor-specific, model-specific, family-specific, and feature-specific tests to say if I am a iOS device, a Catalyst family, or Catalyst model, 6500 family, and I'm attempting to instantiate a port channel or something like that, I can write specific tests for that. All right, so that's enough preamble on it. Let's actually see how it works. So Brad says I'm going to build some more port channels. That's what I'm going to do. That's how I'm going to fix the network. I'm going to build new port channels on our Nexus 7K. All right? So if we look at the way that this is to be done, how many here are, before I go any further, are familiar with Ansible? You don't have to go. Okay, cool. Just real quick, Ansible has the notion of facts or variables on a device, right? So you provide these things called vars. You have host-specific vars and group-specific vars that allow you to say this group inherits these attributes or this metadata, and this specific host inherits these attributes or specific metadata. The way that makes sense is if you take a look at, let's look at our host real quick. So we have one host, which is in our data center 1 or DC1. We have a device called DC1 7K Interop 2019. Okay, that's the host name, or that's the name that we give that device. Now, that DC1 is a group. So in our group vars, we have the DC1 group, right? So in that group, I say that the meta, or just that's the way that we classify for the test. The OS for that is Nexus and XOS, and the vendor is Cisco. So we all know Nexus 7K, that's pretty easy to follow. Then we give it an Ansible network OS, and then a location, which is our top secret data center one, right? It's here in Vegas. But then I have specific host variables for that. And this is where Brad attempts to fix the internet. So for this, this device, I give it a platform of Nexus and a family of 7K. And then I'm going to provide data to the device. So these particular attributes can be used to run a playbook or to query metadata on a specific device. So I'm going to build port channel 375. If you're familiar with networking, you kind of see where this is going. Port channel 375 is a trunk. I give it a description. Then I say these VLANs are going to be added onto this trunk, right, or allowed on this trunk. Now, in the tests that need to be run are port channel tests. Now let's see what template Brad is actually going to use. So if you're familiar with Ginger, familiar with how templating works, you'll see that what we're going to do is say for the interfaces and port channels, we're going to set up this unit of config. So we're going to say interface, port channel, and then the name. And then for the VLANs that are under that other metadata, VLANs under that port channel, we're going to say switch port trunk allow VLAN. So bonus question for any network engineer in the room, what's the matter with what I'm attempting to do? Anybody?
It'll substitute what you have on there for
Yeah, one word missing, right? Add. So Brad, with his newfound way to fix the network, is actually going to remove every single other VLAN on this port channel. Now, if you're a network engineer, you know this is very difficult to catch because this is actually a legitimate command you're going to put on the device. However, Jamal has written tests for this to ensure that Brad doesn't break anything. Now, the way these tests get written in init is you're going to provide it with a battery of tests, and then the tests are going to be set up via feature, right? So under test and port channel, I have a test here, test 01. The data for that is a sample set of data, okay? So I have, for the OS platform family, this specific test is going to just test this port channel named 300, and it's going to test for these 3 VLANs. However, the expected config uses that add word, right? So now I'm going to actually add those values. So rubber meeting the road, how would this actually help? Well, the way that Jamal will set this up, or I'm sorry, the way that this will be set up is you're going to copy your port channel into your family-specific test. Let's do that there. All right. And now I have a separate playbook that actually sets this up. So all it does is it copies your specific test into the init directory so that you can actually run these changes. Let's take a look at how that works. Oh man, if I can type.
You don't just configure this on the network and then just see if it works.
No, we're automating networks here. So we run this test, and all it's going to do is copy this over. If life is fair. All right, first one passed. So now we see in init templates. Boom. So you see now we have a Nexus 7000. Defaults, we have a port channel test that's going to run. Now let's run this. We run this against localhost because we're just running it locally, and we're going to run init test. Let's name that. PB test configs. PB test config. So this is actually going to run the test itself. So, don't flame out. Awesome. So what it's doing is it's loading the data. It is running a test, and it's basically going to say, with the data that was provided, will this pass the linting? Will this actually pass the test that I want to do? So you notice that we have what's called a job summary that gets output. So if you do init job summary.text, what you see here is we have a couple of failures. Right? It's a pretty good diff that we're used to looking at in source control. We also have a couple of failures. So at the top, we notice that we're testing Ansible version 2.8. Python version 3.7. If we had multiple versions, it would run through different tests. We also noticed there's a couple of things that are failing here. So on our interfaces test that was written a long time ago, we noticed that there is no attribute description. That's a simple policy, right? Every interface needs a description. But think about the power that provides. If you have metadata on your interface descriptions, we've all wanted to be able to look at a unit of config and say, what order was this? What is this actually doing? Well, what you can do is you can go a step further and say, not only does this require a description, but it has to match a certain regex pattern, or it has to have certain metadata within that description. We also noticed that in our port channel, we have some failures here. If you see below, down in this port channel area, you'll see that switch port trunk allow VLAN, it should be add, well, the dash is saying that was taken away, right? It should be add 300, 301, 302. What actually the template that that Brad provided will do is it will use that switch port trunk allow VLAN 300. And as was mentioned, it will remove every other VLAN that's on that trunk port. That's a very trivial example, but think back to your days operating networks, how hard that is to catch. It's very difficult to catch a legitimate command that is not going to treat the network in the way that you want it to. Now let's up-level this just a little bit. Let's say Brad is adamant. This means nothing. I really need to push this through, right? I gotta go home, gotta go on vacation, I gotta go run a half marathon with Darren. I need to push this through. So he goes forward, and he says, I'm gonna create a branch. And I'm gonna call this network change 3. and he says, I'm going to push this change through. And he goes so far as to submit that, right? Then go over to our repository, and he goes even further. He's going to submit a pull request against this branch, right? Don't fail me. Cool. Network change 3. He's going to issue a pull request to actually push that through. Make this now. Create the pull request. Now, this is where the CI, the automated CI comes in. We've made GitHub actions that will actually run this battery of tests to see if this change is actually going to work. So, while this is running, because it does take a couple seconds, let's see what GitHub Actions actually looks like, right? So with GitHub Actions, you have a workflow. And the workflow is basically a way that the CI piece of the test is going to run. So what we're doing is we're on pull requests, we're going to run the verified network changes. What the verified network changes is it's going to run that test that we just saw with the NIC. So running that through Ansible Playbook on your local machine, that's cool, right? That is very good. That's an automated way for doing testing. When you start integrating and orchestrating this, we want to actually run this test on every single pull request or every single change that's attempted to be made. And the reason for that is if someone decides not to run the battery of tests, if someone decides to push something through, we still want to have that visual cue to say some change has been made that is a problem, or I need to check it. So now we see our linting was run, and let's just check our log here. So down in the bottom, you should see the output of this. And now if I, as Jamal or Brad's manager, went and looked at this test, I'll see that there's some failures down here. And I would tell them to correct this pull request. So what do we just do, right? It's a lot of words, a lot of demo. Well, first, the demo didn't break, so thankful for that. But what we actually did was show it a way that we can leverage what developers have done for a long time. They've been running these continuous integration tests in order to validate that an application, a new piece of configuration or a new feature that they're working on doesn't break their application. We'll apply that to the network. What we're basically able to do is with very little input, we're able to lint our changes with a very difficult thing to catch and see that and ensure that a change that we're attempting to push through won't cause the network to behave in a way that we didn't anticipate, right? And for the very low cost of absolutely nothing, we're able to implement this very difficult topic. So before we go to the next demo, any questions on that? Any questions on what we just saw? My friend, what's your name?
Will.
Will.
So, imagine that the test is actually wrong, right? So you just implemented this last week, right?
Mm-hmm.
Try and get your team to use it, but it's not right.
Right.
It's not going to be right the first time. How dogmatic do you try to be? And so it's like the right answer would like be, we'll go fix the test.
Mm-hmm.
But meanwhile, people have other work that they're trying to get done, right? So where do you draw that line between ignoring the flaws in your test? There will be sometimes.
Yeah.
And you know, where do you draw that line between allowing people to work around their test or saying, you have to go fix the test? Where do you draw that line?
Yeah, good.
So in the software world, the solution to that is when the tests are broken, when the they say as the build is broken, then the highest priority for the team becomes fixing the build. And that means if the code that you're testing is broken, that needs to be resolved quickly. If it's actually that something has changed in your process, or maybe there are new tests that haven't been thoroughly vetted as well as they could have been beforehand, then the priority is fixing those tests, because everybody has to go through those gates. Those gates are what keep us safe. Those gates are what are what our executives use to say, well, I guess it's okay if you guys go do this automation thing as long as there's enough protection around it, right? So that protection has to be right, and you have to focus on that as a priority as a team. Going around should not be an option except in the most extreme of emergencies.
We have seen friends in the industry that we work with that have implemented that no change goes into effect unless it has a test, right? And it's a very hard line to draw in the sand, but you see how it has benefits to it. And so it's a culture change, and we like to pair up with those that may be network experts to say, what show commands would you run on this particular change? What would you like to see? And that enables us to write tests that will facilitate that. But that's an excellent question. Any other questions? All right, now we're going to,
Did you get time?
Yeah.
So in the test, which I think is important, it almost seemed like both people were writing the same config, right? The engineer wrote a config, and then the boss wrote the config as well. So what are your thoughts on other ways to test rather than just comparing like your boss's config to your config?
Yeah, very good point. Good question. Answer is still in progress. One of the things that we did there was we showed a sample set that compared an expected config versus a template. And what it basically, I did a very poor job explaining, Jason will probably be better, but what it basically does is it takes the template that you're going to run and the data that you're putting in and compares it against the sample set. We think that that methodology is legitimate and is beneficial, and you can kind of grow that exponentially. So to your point, we may not just be comparing a sample set of data. We may actually go and say, what's on the device now, right? And what is the current network state, and how will the changes that you're going to actually run impact the network state? And that's a part of the testing framework or the testing that we're doing. This one was a very true example because I only had an hour that showed just linting and what that would get you, but testing, CI testing in itself, not even CD, but CI testing for networks is constantly a work in progress. We're looking at PyTest, test infra, and how we can get kind of a higher level to say, is the VLAN range that you're doing valid against our CMDB, right? Is the interface that you're operating on in these interfaces this interface range that we allow someone to work on? So that higher order of testing comes with working with kind of higher order of tools too. So yeah, very good question.
And we'll be going into some other options or some additional things that you can do with testing in another session as well. So we'll go into a few other things there, but it's the different components, the different pieces. So testing config is great, and I think that's really easy for a lot of people to understand. It's really concrete, but then when you start talking about intent, when you start talking about mathematically being able to prove that the intent or that what you did matches the business goals, there's a whole other realm there. Your next level from making sure that the config is right would be doing operational validation. And there's a variety of tools that can do that. So it's just a matter of working your way through the different levels, starting with some basic testing and building upon that and start going into more depth.
Good question, thank you. All right, we're going to go to our second scenario, kind of the swing for the fences, as it were. So the next scenario is all the buzzwords, right? All the things that we love, right? AI, ML, neuro-linguistic programming, or natural language processing, chat apps, automation, intent-driven, cloud native, all the things that we love and hear so much from vendors. We're going to implement that all in one crazy change. And what we're going to do is integrate Google Assistant with a network change, with a scenario we like to call Darren went to the bar. Okay? So to set it up, Jere comes to me and says, Darren, did you put in your tickets? I say, yeah, I put in my tickets. Did you put in your tickets? Yeah, I put in my tickets. Darren, did you put in your tickets? This is a very serious change that impacts the entire network. I say, Jere, I put in my tickets. I say, cool, you got to run this change at 7 o'clock tonight. I say, perfect, I'm going to do it. However, get home, the wife says let's go to the bar. If you look at me, you can tell I like the bar. So what do? I go to the bar. And what happens? I leave my computer at home. 6:59 rolls around, IPA, pull up to my lips, and I say, it's something I was supposed to be doing. And the waiter comes back and says, do you need any change? I have a change that I'm supposed to put through. All right, I'm not a stand-up comedian, but you get the drift, right? I'm somewhere where I don't know how I'm supposed to actually implement this ticket. That's where these crazy things that developers have been using come into play. That's where, if you do it the correct way, through opinionated interfaces, you can integrate a crazy thing like Google Assistant or Alexa with your network. Now, why would you want to do that? Because it's cool. And it gives you the ability to be at the bar and run your network changes because you've already done the linting and the testing to ensure that you're not going to break the network. So let's set this up just a little bit. Google Assistant is basically just an Alexa, right? Or a kind of impersonating Jarvis, where you see Iron Man. And so what you can do is you can talk to it. You can say different things to it and have the notion of bots or listeners on Google Assistant. You can create one for the network. We called ours Network Ninja, right? And this that we created for the network is using what's called dialog flow. We picked Google Assistant just out of the blue. We were looking at Alexa, but we picked Google Assistant. It'll work the same with any of them or any of the custom ways that you do it. Essentially what it's doing is it's giving you the ability to leverage chat apps with the network. So that diagram that we saw with all those blue arrows, add one more for actually using a crazy thing like Google Assistant. Now, to set this up, I'm just going to show a bit of what commands this actually works with. And I'm not going to take, one second. I'm not going to take any shine from my illustrious colleague that's going to show more about Slack. But I just want to show essentially how this works is we have these commands, right? Now these are what we call slash commands. So within a chat client, you have these special commands that will invoke a certain action. We're taking that a step further by running it from our phone at the bar. So this particular action, let's say I just want to add a VLAN, for example. It's going to go out and it'll provide you with kind of some feedback. And it'll say, select the switch. Interestingly, this is actually going out to our source of truth, Netbox, and saying which has the metadata of switch. Which of these devices are available with switchboard configuration, right? Then, in addition to that, you have VLAN name and VLAN ID. So this is a very small change, something that you may want to push through. You may want to give your users the ability to run this all the time. But you also see net switch config switch port management will do kind of the same thing, but this gives you some more options. You have interfaces, device type, speed, and duplex, right? So that's the basis for this demonstration. Where this is actually getting run is interfacing with our ServiceNow instance. Hopefully you can see that. So ServiceNow is, love it or hate it, it's the ticketing system that we're using. ServiceNow is where when Jere asked me, hey, did you put in your change? I put in my change. I put it in to ServiceNow. Let's actually do that real quick. So we're going to do a switch port management. This is the change that needs to be run at 7 p.m. this evening. So I go to this. You notice this takes a second, right? Because it went out to Netbox and say which devices are available to configure for this. We're picking Nexus Spine 1 because that's the one I tested and I know it works, and you don't do something you haven't tested during a demonstration. We're also going to pick an interface. Let's pick 2.7. I want to show VLAN ID 500. Device type is computer. Description is for Jere. Let's just auto the rest. Don't take too much of your time. Business justification is Jere told me. Request notes. Do it later. 5/20. Okay. So when I submit this, you're going to see an alert. It says, please choose either VLAN ID or device type. Now, the reason why we're going through all of this is to say, in order to integrate with these higher level tools, you have to have some guardrails around, some opinionated interfaces. Now, I don't know if you can see that alert. What it's saying is choose a VLAN ID or a device type. Right? If you have port profiles or things like that, you know how you can set a certain profile for a certain type of device. Well, because I selected a device type of computer, it's already going to infer what the VLAN should be. So I can take the VLAN out. Now I can submit this ticket. And the ticket should be at the top of my list. Cool. All right. Now we go into this ticket and do one quick thing to prep for the demo, because again, you don't do things you haven't tested. I'm going to assign this to T'Challa. All right, that's the Network Ninja's user. T'Challa is the Black Panther. Hopefully you watch the movie. That's it. Now, for the prestige. So I'm at the bar. I decided to myself, I need to run this ticket. And I'm going to do it by invoking the Network Ninja. So, do that. I use my phone and say, okay, Google, talk to Network Ninja.
Sure, let's get Network Ninja. I am the Network Ninja. How can I help you?
Show me my available tickets.
You have 2 open tickets. IDs CHG0030581, CHG0030580.
Show ticket details for 0030581. I need to make sure this is the right ticket, right?
Ticket description, demo, switchboard management.
Execute ticket 0030581.
Executing ticket CHG0030581.
All right, cool. So it executed the ticket. Now what did it actually do? Well, shut up. Let's go to the things you've tested, right? Let's go to our Slack instance. And let us hope that in this channel, at some point, we're gonna see some feedback. And let's go to Tower. If you buy me a beer later, I'll tell you about my username. Let's go to jobs. Okay, kicked off the job. Cool. So I have from my phone, from Google Assistant, while at the bar sipping an IPA, made Jere's life a little better because I'm able to run a network change from my phone. Now, what this change is actually doing is it's running a playbook that we wrote months ago. And it's doing so based on the guidelines and guardrails that we set up years ago. And so it's an opinionated, controlled interface in a way that we can use some higher level applications that are really cool and absurd to actually run a network change. Now, if we, life is fair, man, this is going great. So we're seeing that the feedback is in Slack. So Jere is sitting here in this automation demo repo. Let's, for example, just say that's called changes. He's tapping his fingers. And when is this change going to come into play? I got the load balancer person calling me. I got the web services person calling me. But now he starts to see this feedback. What you notice is I'm updating a VLAN. I'm creating a VLAN. However, the ticket that I put in was for switchboards. But because I chose a profile of computer, it's inferring and adding the VLAN of 10 on the particular switchboard that I selected. So we see that we take a show VLAN brief, a pre-change, capture. Then we show the unit of config, the automation piece that we're actually going to instantiate. Then post-change, we show that in fact, it was actually put into place. And then we show the port. And finally, we show what's being deployed. And again, if life is fair and this place is great, you're going to see in a second, there's a status. Move to review. So throughout this playbook, what we're doing is we're moving to different steps. But let's say, for example, Jere saw this and it sent him a note that said, hey, you need to go review this. So he goes to review it. Now what's also important is all of this metadata is being put into the ticket. What's one of the things we can't stand about tickets is putting in your backup scripts, putting in all the metadata that's necessary to make these changes and make our higher level governance, our cab calls, and those people, make them happen. Network engineers, we just want to run these changes. I don't want to do all that. Or you can make the network do it for you. And what we essentially did was we went and configured this particular switchboard, very trivial change, and we made sure that we could run that from Google Assistant. And if you look at this ticket, now I'm just refreshing ServiceNow, the ticket went away, right? Because it was put into place. Let's ask the Network Ninja again, because now I'm on to IPA number 3. They need to make sure that this ticket actually went into play. Okay, Google, talk to Network Ninja.
Sure, let's get Network Ninja. I am the Network Ninja. How can I help you?
Show me my available tickets.
You have one open ticket, ID CHG00305880.
Alright, so my ticket went into play. So from the bar, between IPA number 2 and 3, we actually sent through a network change. And what did that really do? Well, that made Jere's life happy. I kept my job. My wife's happy because we're enjoying ourselves. And I got to do something really cool with a crazy tool, something absurd. Now, how do we actually make that work? I don't want to take up too much more of your time, but we are here throughout the day and throughout lunch. We have a calendar set up where you want to talk out afterwards. I can tell you exactly how we did this. We're going to open source the code. It's nothing for the Google Assistant. It's nothing special. I am not by any means a good JavaScript developer, but myself along with a couple colleagues, we hacked our way through it. So what we're basically showing is that using these tools, you're able to let people access the internet, access the network, and access your network function in a controlled way, and do something that is particularly crazy. Now, just in case the demo failed, I had an example of what we actually did. That's what you would see on the screen. And if time had permitted, I would have walked you through actually doing it from the computer. But instead, I just want to leave you with these 2 takeaways. Right? 2 things that you can take away from this talk that Jere and I gave. And that is NASA and ISAM. NASA is networking ought to be sexy again, and ISAM is I suck at mnemonics. So, any other questions?
So you assume that your uplinks were configured correctly. So what if your uplinks are not configured for that VLAN, then your change failed?
Yeah, I would have had to leave the bar. But no, you know, he said that, I'm sorry, he said that I assumed that my uplinks were configured correctly, and if they weren't configured correctly, the change would have failed. So the point with that is, first, you know, for a demo, obviously you can and make it as nice as possible, but the assumption is those things that we saw, like the Slack integration, the change management, the guardrails, they were already there. So prior to that change, would have run a pre-change or a check that would have said, are my uplinks configured? If not, fail. The cool thing is you can talk right back to Google Assistant or Slack or something and give that same feedback that you saw in the Slack tool, you can give that to whichever way that you're accessing the network. So if it's a ticket, you can give that feedback back to a ticket. Hey, pre-change failed, ticket got kicked out. If it's someone at a bar using Google Assistant, you can do that. But excellent question.
Your playbook could have check all of this.
We did quite a bit. So in that playbook that you saw there, everything that you saw being moved through is just a play or a task in the playbook, right? So the pre-change is really an operational show command that we run on the network equipment. So you could say, is this uplink configured? You can also reference, let's say that I'm setting up a trunk or I'm setting up a VLAN. I want to check its neighbor to see if it's configured on that neighbor, so I don't configure something that won't work. You can reference another host or another device in those operational changes. You can get really crazy with that operational validation in order to leverage things that aren't host specific. So you could do it for sure. And then you can have gates that say if at certain points in that test or in those show commands, it would have failed if I had input something incorrect. So yeah, very good.
And not only that, if you had happened to be between beers 6 and 7 at that point, you don't have to worry about whether Darren remembered to run all of the pre-checks that he was supposed to in your mock, because they've all been encoded. So as you build those up, you know from experience, sometimes not so good experience, but you know from experience what you need to check before you make such a change. You encode those in. Don't put them in a Word doc. Don't put them in a spreadsheet. Put them in some code, and now everybody that runs that set of tasks will run those exact same pre-checks the exact same way every time. Nobody forgets. Nobody fat fingers anything. It's consistent.
Yeah, that 3 minutes that you saw running that CI through the workflow, that's a few minutes. Some of them run for hours and run constant pre-checks. And in the past life, we had one that ran for 45 minutes because it was checking through different devices to make sure that the change you're going to put in doesn't impact something incorrectly. Any more questions? My friend.
So, what is Network Ninja? Is it like some sort of tool which you guys made, or is it like some external tool? Is it open sourced or anything?
Yeah, well, good question. So that Network Ninja, really what that was a bot that was created using Dialogflow on Google Assistant, and you just have to give it a name. So that's the name I chose. And what it does is it invokes, you heard of AWS Lambda?
Yep.
Google has the same thing, they're called Cloud Functions, but it invokes Cloud Functions for every single request that you make, right? So when I said tickets, it triggered the get tickets function, and that function called ServiceNow and said what tickets are open for the user that I'm calling from. We're gonna open source the code. I just gotta clean it up a little bit because I was typing feverishly, and I'll send the link out to you. And if you want to see me afterwards, I can walk you through it. I ain't that smart, and I was able to do it, so I know you can. Any other questions? For him. Yeah, so that's an excellent question. The question was, can you roll back? Yes, and again, we have put into place requirements that every change that is a do also requires a negate, right? So something as simple as configuring a VLAN on the switchboard, that's the one that, my trunk point that comes up. Maybe you're just doing VLAN add, where you do no VLAN and the number, right? In each one of the changes that you're sending, you also need to have a converse in it. So yes, you can roll back. You can roll back automatically. In line with our gentleman's question before, the thought is you probably do that at a stage in one of the gate tests that you're running, right? So you run a test to say, post change, what is the state of the network now? And then if the network is not behaving in the way that you want, if the tests aren't passing, then you go to the nullified version of that change, right? So I can give you a concrete example, but I don't want to, let me not do that. But
I'll mention it when we start back up, actually. Talk through rollback.
Yep.
We got to take a break right now. So right now, 10:30, hard stop for a break if we want some coffee out there. And thank you, Darren. Thank you, Jere. Great demos.
yeah.